Hi there. Today we're going to be talking about transversals and simplifying equations. And it's not all that hard. There's some drawing to it, so you might want to get out your straight edge because you'll need to do some drawing. First of all, we need to know what a transversal is. And a transversal is a line that intersects one or more other lines in a plane. For our purposes, okay, and that's, for what we're working on now, we will limit our work with transversals to intersecting a pair of parallel lines. So, here's where the straight edge comes in. You need to draw this in your notes, okay? You've got line L and line M, and they are parallel to each other. And then you have T, which is our transversal. Now, when T intersects line L and M, it creates a lot of angles. To be precise, in this case, it creates 8. 1, 2, 3, 4, 5, 6, 7, 8. So you need to draw the parallel lines, the transversal, and you need to label the angles. And be sure you label them correctly, because as I refer to them, if you don't have them labeled correctly, you will be confused. Okay, so if you have that in your note, this transversal does result in 8 angles being formed. If you were to have 3 parallel lines, then you would actually end up with 12 angles, 2 sets of 4. All right, going on. I have redrawn the same lines, only this time I have labeled them with letters, and that's what you need to do. I've redrawn the same set of lines, and I have the transversal is going a different way, and that's okay, it can do that. The first transversal I had was going this way, it had what I guess you would consider as more of a positive slope, and this transversal has more of a negative slope. So we talk about slope a lot, so that works. Again, you have 2 parallel lines, L and M, and transversal T. Please label your angles A, B, C, D, E, F, G, and H. So get out your straight edge. Now, the red line labeled T is the transversal. Lines L and M are parallel lines. The measurement of angle A, and I'm giving you something really important here, the measurement of angle A is 64 degrees. So we're going to go back up here. We're going to back up for just a minute because we're going to label all these angles. Angle A is 64 degrees. So I'm going to write 64 right here. Now, we know that this is a straight line. And a straight line has 180 degrees. So if this angle here is 64, then to figure out what this angle is, we're going to take 180 and we're going to subtract 64. So let's do that. Okay, so now we know that this angle here is 116 degrees. Okay? So if this angle is 64, then this angle over here is its opposite friend. And 116 plus what makes this straight angle? So there's 2 ways to tell what this angle is, but it is also 64 degrees. And if this angle here is 64 degrees, and this is a straight line here, straight line, then this angle's got to be 116, right? So we're going to go that far, and then in a minute or two we're going to talk about how we can figure out these angles down here. Okay, going on. It's important to know relationships between angles. You have vertical angles, or sometimes they call them opposite angles. These pairs are congruent. So our vertical angles are AD, BC, FG, and EH. So let's go back and look at them. AD, BC, FG, EH. Remember, they are congruent. AD 64, BC 116. Now we go down here and we're like, Well, we know that E and H are equal, and we know that F and G are equal. We'll come back to those and talk about what their measure is. Okay, obtuse angles are angles that are over 90 degrees. We know that B, C, F, and G are over 90 degrees. Oh, let's go back and look. Okay, B and C, F and G. We'll look at them. You can just look at them and tell that they're over 90 degrees, can't you? And you can tell these guys here are littler angles, so they must be our acute angles. And again, these would also be acute angles. I see kind of a pattern here, okay? Notice that you have this angle right here that's above this transversal line, it's above this parallel line. It's 116 and is an obtuse angle. Now, my guesstimate would be that this one will also be 116 because they are corresponding, okay? And if this one's 116, then we automatically know its vertical friend here is 116. And of course, if this one's 116, then 180 minus 116 gives us this one at 64. And if this one's 64, then its vertical friend has to be 64. So now we have every angle labeled with its degrees. These are vertical, vertical. These are obtuse, obtuse. These are acute, 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 and acute. Okay, so we have some things to write here. Our obtuse angles, our acute angles, I've already talked about. They're less than 90 degrees, angle A, D, E, and H. We have supplementary angles that add up to 180 degrees, and those are very easy to figure out. We've already identified them as we were figuring out the measurement of our angles, but I would like you to write a list of them. So they are down here at the bottom. Supplementary angles, that means two angles that add to 180 degrees or a straight line, okay? You've got AB, BD, BC, AC, EF, FH, HG, and GE. Those are all what I would call supplementary angles because when they are put together, they are more than, or excuse me, they are 180 degrees as in a straight line. Okay, now we need to talk about corresponding angles, and to do that, okay, we have to draw yet another set of parallel lines and a transversal. Corresponding angles, their positions correspond on the side of the transversal, either above it or below it. Okay, so first we're going to talk about corresponding angles. Angle B and angle F are corresponding angles because they are both above the line and they're on the right side of the transversal. They're above the line, they're on the right side of the transversal, and guess what? They're going to have the same degree measurement. And if you go back and look at our last page of notes, you will notice that this one has a degree measurement of 116 and this one has a degree measurement of 116. Okay? Now, over here on this side, you have A and E that are in that position. Okay? And A and E have measurements of, you got it, 64 degrees here and 64 degrees here. And likewise, C and G would be corresponding angles. They're in the same position below the line and on the left side of the transversal, and they would be 116 degrees each because they are equal. And then you have D and H are corresponding angles. They are on the right side of the transversal and they are below the line, both of them are, and they both have measurements of 64 degrees. A lot of ways to find the measurements. Okay? Now, you notice I have some pretty colors on here, and that's to show you interior and exterior. Okay, and looking at the lines, we see we have angles that are within the parallel lines and angles that are outside. The ones that are within the parallel lines, these angles right here, these four, are interior angles. The ones outside the parallel lines in the pink, those are exterior angles. And there's a relationship between them as well. Okay, there are relationships between interior and exterior angles. We have alternate interior angles and we have alternate exterior angles. Now, if you're thinking alternate, you want to think about taking a step. If we were going to step over the transversal and stay inside the lines, we would go from here to here. We'd step E and then we'd step with our right foot on D. Notice that the measurements are the same of those angles. Same way with if we stepped on F first, then our left foot would step on C. Notice those measurements are the same. So, alternate interior angles. Now, if we were going to take big monster steps, we would step from G, left foot, to B, right foot. These are alternate exterior angles. They are outside of the parallel lines, and they're big steppers. You avoid the middle entirely. So you have G to B, and they're both 116. If you start with your right foot on H and go H to A, you have 64 degrees on both of those, and these are alternate exterior. So you have alternate interior, and you have alternate exterior. Very, very important. Will you please write the sets of alternate interior down in your notes and the alternate exterior? Each pair will have both interior, exterior will have both the same measure, and I already showed you that. So C and F will have the same, D and E will have the same, A and H will have the same, and B and G will have the same. Whether they're on this transversal or, you know, their locations tell you that their angles will have the same measure. Okay. All right, part 2 of this lesson is all about simplifying equations. So we have to know how to look at equations to simplify them, and really the most important thing is to gather up the like terms before we solve them. So these are pretty easy. The hardest thing though is to figure out what a like term is. Sometimes I think people think that you can add 3x and 4 and get 7x, and that's not true. You can't do that. You need to think about getting numbers and variables together. Okay, so for instance, on this particular problem, this is our first example, we have 4n minus 5 equals 2n plus 3. We've got n's on the right, we've got numbers on the left, we got to move things around. So this is definitely more than a one-step problem. So I think the first thing I would do, and this is my practice, is I like to move the numbers to the right and I move the letters to the left. So the first thing I'll do, I just take one step at a time. I'm going to add 5 to both sides. Since this is a minus 5, I'm going to add it to both sides. So this goes away, okay? And we end up with 2n plus 5 plus 3, which is 2n plus 8. Okay? Now, we got the number moved over. We got to get the letter moved over to this side. Okay? So now we are going to subtract 2n from both sides to get this 2n over here. And we take 2n from 4n, and we get 2n. Now, you can't forget this 8, so it goes down here. And now you're going to divide so that you can get rid of that 2 with that n. Divide both sides by 2. This becomes my well-chosen 1. And this becomes 8 divided by 2, which makes n equal to 4. Okay, did you follow that? It's really not all that bad, and it's really not that hard. If you have questions, you'll just have to ask me in class. All right, this is the last page. I'm going to go over 2 more. I think I have 2 more problems. Okay, so here's another example of a problem that we'd have to solve. We have 3x minus 2 times the quantity x minus 4 equals 32. First thing I'd like to do is change the subtraction to a plus a minus. So this changes to plus, and I put the negative sign on the 2. This changes to plus, and I put the negative sign on the 4. That just makes it easier. Now I've got all I've got all addition. The next thing I would probably do is take 3x plus, and then I would go ahead and distribute, and that's back up here on this step. You're going to distribute that -2 times the x, and then the -2 times the -4. Using the distributive property, end with -2x plus -2 times -4. Okay, now you have 3x plus -2x plus 8, because negative times a negative is a positive. Now you can combine. You can combine that 3x plus the -2x. Well, they're negative and a positive, so you end up with 1x because the 2 is the smaller. Now you have x plus 8 equals 32. Again, you're going to subtract the 8 to get rid of it from here, and take 8 from 32, which gives you 24. Your x is already just an x, so x is 24. This takes practice, and you just have to be patient and do one step at a time so that you know what you're doing. One more example problem, and then I'll let you go. 3x equals 2 times the quantity x minus 4. Okay? Again, first thing I would probably do is change this negative to a plus a negative. Okay? So that's the first thing I do. Then I'm going to use the distributive property and take 2 times x plus 2 times the -4. So here I did it there. Then my next step, of course, is to do the multiplication. So you end up with 3x equals 2x plus -8. Now, I've got to get that 2x over to the left-hand side. So I'm going to subtract 2x from both sides. Well, that means this goes away, and I take 3x minus 2x, which just leaves me with x, and I bring my -8 straight down, and guess what? That's my answer. So, this was a little long, I'm sorry, but it is necessary, because this is the fodder for the stuff that you'll be doing next year, and you really need to know how to do it. And we'll do some practice problems. We'll have a day where we do some practice problems so that you get better at it. Okay, thanks a lot. I hope you enjoyed this. I hope you have a great day, and I will talk to you later.